May your morning be colorful, joyful, and blessed. This is Mrs. Rose and V. Parane from Payapa National High School, and we are on our way to Grade 9 Science, Quarter 1, Lesson 1, the Quantum Mechanical Model. This video is for the overview on how to do Electronic Configuration Part 1. But before we proceed to our discussion proper, let us have an overview of the quantum mechanical model. At the beginning of the 20th century, a new field of study known as quantum mechanics emerged. One of the founders of this field was a Danish physicist, Niels Bohr, who was interested in explaining the discrete line spectrum observed when light was emitted by different elements. Bohr was also interested in the structure of the atom, which was a topic of much debate at that time. Numerous models of the atom had been postulated based on experimental results, including the discovery of electrons by J.J. Thomson and the discovery of the nucleus by Ernest Rutherford. Bohr supported the planetary model, in which electrons move around a positively charged nucleus like the ring around Saturn, or alternatively the planets around the Sun. But before we go further, let us have our objective. At the end of the lesson, you will be able to: number 1, determine the characteristic color of the light that metals emit. Number 2, relate colors of the light emitted by metals to the structure of the atom. Number 3, infer that electrons can stay only in definite energy levels. And number 4, identify the energy levels, sublevels, and atomic orbitals in an atom. So the quantum mechanical model is the most advanced and accurate model of the atom. It is used today by chemists and physicists. In this model, electrons do not exist as tiny points inside the atom, but instead surround the nucleus in a form resembling a cloud. Bohr's atomic model describes the atom like a solar system, where the considered electrons as particles moving around the nucleus in the specific circular paths called orbits. These orbits are found at fixed distance from the nucleus. You can refer to the image or video animation on the top. Three physicists led the development of better models of the atom. So these were Louis de Broglie, Erwin Schrödinger, and Werner Heisenberg. De Broglie proposed that the electrons, which is thought of as a particle, could also be thought of as a wave. While Schrödinger used this idea of de Broglie that electrons are wave particles to develop a mathematical equation to describe the probable location of an electron around the nucleus. While Heisenberg discovered that for a very small particle like the electron, its location cannot be exactly known. This is called the uncertainty principle. So these scientists believe that there is only a probability that electron can be found in a three-dimensional space around the nucleus called the atomic orbitals. So the quantum mechanical model of the atom describes the probable location of electrons within the atom using atomic orbitals that you can see on the animation. There are different kinds of atomic orbitals that can differ in the amount of energy and shapes where the electron probably is. Okay, so during the New Year's Eve, ano-ano yung mga colors ng fireworks that we seen on the sky? Correct. There are blue particles, white, yellow, red, orange, violet. All of your answers were correct. But let us watch a video about the flame test wherein pinapakita dito kung ano yung mga ini-emit na colors ng bawat elements. Let's watch this.
Apologize, you can't see my face. I don't want to get it very close to the Bunsen burner and set my hair on fire. But what we're going to look into now is what we call the flame test. Some experiments call this one the firework colors. So let's look into that a bit. So fireworks are made out of hot embers of metals. And it turns out that many of the metals on the periodic table have a characteristic color when they burn. Okay, and this color happens from extreme temperatures where they are hot enough to excite the electrons. Now, every atom is going to be different. Therefore, the number of electrons on their outer shell is going to be different. And also, distances from one electron shell to the other will be a little bit different as well. This is why we get such a variety of colors. When you excite them, the electrons jump up to an excited state where they're further away from the nucleus than they want to be under those the energy that you've given it, and then it wants to release that energy, so relax, will come back down to the ground state, or close as they can be to the nucleus, and as they jump down, every jump back towards the center is going to release pockets of energy, okay, quanta of energy, and it's usually expressed as light, frequencies of light. So if we got low frequencies, we should see colors like red. If we see high frequencies, we should see colors like purple. But let's look at the main constituents. Most metals will actually make a white color. So let me just cut off the lamp here. And we're now going to look at magnesium. Now this one here is incredibly bright, so my assistant will just make sure that he's not looking directly. He can look to one side. And then once it catches, we have a very bright white flame. And this is what you would normally see as they arc through the sky. That's probably going to be magnesium. Zirconium also makes really bright white colors. My assistant is going to go for a different substance. So this time we're not going for the raw metal itself. We've actually got the metal in solution, sodium chloride. Now sodium will still make an influence on the color of this flame here. So if my assistant puts it in, we get a very orange-yellow flame, and it's very bright. And this color is the same color you would see on motorways, like highways, where they have very cheap sodium vapor lamps. So that gives it that yellow color. If you have this kind of lamps on your street side and you're trying to figure out the difference between the recycling bin and the general waste bin, you may not be able to tell them apart because that yellow is so intense. Yeah, potassium chloride. This one's very difficult to see. It's going to give us a pale purple. We call it a lilac color. It looks like we're not going to have much luck here. We're getting mostly the color of the wood burning in this situation here. So we might try a different chemical. Now what he's putting through the flame is actually a matchstick. This matchstick has been soaking overnight in these different chemicals. And the chemicals are all the same, so they're all some form of chloride compound. The only thing that we've got different between them all is the metal. So if we see a difference in color, it's going to be due to the metal and not because of the chloride. Barium. So barium's going to give us a very orangey yellow as well. Let's go for strontium next. Now, strontium is going to probably look more familiar to us. A lot of the fireworks will have the big red as part of their explosive, plumes. Red is most likely to be a result of strontium, because strontium gives a beautiful, dark, deep red color. We're getting a little bit of wood burning, but that's unavoidable. But the majority of this color, I think you can see, is that red flame. There it goes. We've lit the toothpick on fire. Copper chloride. So this is copper metal, mainly at work here, giving us a color of our flame. Giving us a beautiful green, Harry Potter green color. And now it looks like we're just burning at this point here. So those are some of the chemicals that are famous for giving you colors of the fireworks. When they explode, they burn with little bits of these trace elements, and that's what gives us our different colors. If you want to learn more as to this whole electrons being excited and relaxing to create these different colors, I do have a video about this where I'm jumping down a staircase looking very...
Okay, so the fire effects are produced by the combustion of explosive materials present in fireworks. These explosive materials are also called metal salts. So metal salts emit characteristic color of the light when heated, as shown on your table number 1 on your printed module. So you are going to answer the 2 guide questions. The first one is, what can you conclude about the elements and the colors of the flame produced? Number 2, if sodium nitrate is changed to another salt of sodium, for example, sodium chloride that is seen on the table, so do you think the line color of the flame would be the same or different, and why? So each color of light has a specific wavelength among the visible light. Red light has the longest wavelength and has the lowest energy. So to get to know more and to explore ourselves on atoms, let us have another video.
This video lecture will provide you a recap on writing an electron configuration, and it will also serve as a preparation for the topic on understanding the quantum number, which is present on MELT number 6 of Science 9. Are you ready to learn on how to write the electron configuration of an element? If yes, let us start our session. Electron configuration is the arrangement of electrons in energy levels around an atomic nucleus. Further, it is the shorthand representation on how each electron is arranged among the orbitals, levels, and sublevels. Usually, sa tinatawag nating electron configuration, makikita natin dito na ito ay represented ng numbers, letters, at superscript. The number corresponds to the principal quantum number, whereas it designates the energy level of each atomic orbitals in which the electron moves. The letter presented on the electron configuration represents the different orbitals or sublevels. Meron tayong 4 na uri ng sublevels. Yun ay ang S, P, D, at F, kung saan ang S ay tumutukoy sa sharp, P for principal, D for diffuse, and F for fundamental. Superscript represents the number of electrons that can be accommodated in a particular sublevel. Ang bawat sublevel ay may kanya-kanyang maximum number of electrons na kayang i-accommodate o hawakan. Halimbawa, ang S sublevel can accommodate with the maximum number of 2 electrons. P sublevel can accommodate with the maximum number of 6 electrons. D sublevel can accommodate with the maximum number of 10 electrons. And lastly, the F sublevel can accommodate with the maximum number of 14 electrons. Tulad ng ating nabanggit, hindi dapat lalagpas sa maximum number ang distribution of electrons sa bawat sublevel. maaari tayong maglagay ng mas mababang bilang, ngunit hindi dapat ito lalagpas sa maximum number of electrons. I-relate na lang natin kapag tayo ay sasakay sa isang elevator. Alam naman natin na ang isang elevator ay merong maximum capacity of passenger lamang. Kapag na-meet na ng elevator ang kanyang maximum capacity at halimbawa na sa isang sitwasyon ay may dumagdag pa o lumagpas na ito sa bilang ng kaya lamang nitong isakay, hindi ito gagalaw o hindi ito aandar patungo sa iba't ibang floors ng building. Ganon din sa mga sub-levels. Kapag sumobra ang bilang ng electron sa sub-level ng ilang element, maaari itong magkaroon ng problema in terms of interaction with other elements. Magbigay tayo ng halimbawa ng isang element na isusulat natin ang electron configuration nito. Halimbawa, subukan nating isulat ang electron configuration ng element na aluminum. Ito ay may element symbol na Al. Ngunit, paano nga ba natin isinusulat sa tamang paraan ang electron configuration ng isang element? Gamitan natin ng step-by-step procedure upang mas madali nating maunawaan ito. Step 1, we are going to determine the atomic number of the element that we are going to use. For us to determine the atomic number of an element, we are going to use the periodic table of elements. Using the table of elements, we know that the atomic number of an element is always presented on the upper portion of the element symbol, just like this. Minsan, makikita natin ang atomic number sa upper right or upper left portion ng element symbol, depende sa version ng periodic table na gamit natin. Siyempre, mas maganda na ang gagamitin nating version ng periodic table ay yung updated na kung saan fully filled na ang bawat blocks nito. Batay sa ating illustration, ano ang atomic number ng element na aluminum? Tama. Ito ay may atomic number na 13. Matapos nating malaman ang atomic number ng element gamit ang periodic table, mag-proceed tayo sa susunod na step. Step 2, we are going to use the electron configuration mnemonics device for us to know the proper arrangement of the energy sub-levels. Kailangan nating gamitin ang mnemonics device na ito upang mas maayos nating matandaan ang tamang pagkakasunod-sunod ng paglalagay ng number of electron sa bawat orbitals or sub-levels ng isang element. Bukod sa dalawang steps na ating nabanggit, in writing the electron configuration, there are 3 rules or principles that we need to follow. This serves as a guide for writing the electron's location to be easily predicted. The first principle is what we call Aufbau principle. Aufbau is a German word which means build up. This principle states that the electrons fill first the first orbital of the lowest energy until any added electrons occupy the available orbital of higher energy. Ibig sabihin lamang nito na magsisimula tayo sa pinakamababa hanggang sa maabot natin ang pinakamataas na energy level sa pagdidistribute ng number of electrons. Sa second principle na tinatawag nating Pauli's exclusion principle, it states that no more than 2 electrons in an atom can occupy an orbital. Further, the pair of electrons must spin in opposite direction. Mapapansin natin sa bawat sub-levels, ito ay may respective number of electrons na kayang i-accommodate. Isa ito sa kailangang bigyang pansin sa Pauli's exclusion principle. According to this principle, electrons are said to be paired if 2 electrons with opposite spins occupy an orbital, and unpaired if a single electron is present in the orbital. Dito, makikita natin na batay sa maximum number of electrons ng bawat sub-levels, dito natin malalaman kung ilang orbital meron sa bawat sublevel. Sa S sublevel, meron itong isang orbital dahil sa bilang ng maximum number of electrons na kaya nito i-accommodate. Sabi sa Pauli's exclusion principle, isang pares lamang ng electron ang pwedeng i-accommodate sa bawat orbital. Samantalang sa P sublevel, ito ay magkakaroon ng 3 orbitals sa kadahilan ng ito ay may maximum number of electrons na 6. Samantalang ang D sublevels, meron itong number of orbitals na 5 dahil mapapansin naman natin ang maximum number of electrons ng D sublevel ay 10. Samantalang ang F sublevel ay may 7 number of orbitals kung saan ibinatay natin ito sa 14 na maximum number of electrons na kayang i-accommodate sa sublevel na ito. Lagi nating tandaan na 1 orbital must accommodate a pair of electrons, gaya ng sinabi sa Pauli's exclusion principle. Sa pangatlong tinatawag nating Hund's rule, it states that for a set of orbitals, electrons occupy orbitals of equal energy. Electrons enter each orbit until all orbitals contains 1 electron with parallel spin. Nakita natin sa Pauli's exclusion principle na sa isang orbit, ito ay meron dapat na isang pares ng electrons kung saan opposite ang kanilang spins. Sa konsepto ng Hund's rule, ilalagay muna natin sa bawat orbitals ang number of electrons using a representation of a ray facing upwards. Matapos nating mailagay sa bawat orbitals ang unang electron, mapapansin natin na parallel ang mga ito sa bawat isa. Matapos nito, tsaka pa lamang natin ilalagay ang magiging kapareha nito kung saan ito ay represented naman ng line ray facing downward. Ito rin ang isa sa ipinapaliwanag ng Pauli's exclusion principle kung saan ang pair of electrons ay may opposite spin. Mapapansin natin na magkakaroon ng pagkakataon na sa orbital ay magkakaroon ito ng paired electrons sa pinakamataas na energy level. Kadalasan, ito ay maaari ding magpakita ng unpaired electron sa pinakamataas na energy level. Ipinapakita naman ito kung ang isang element o atom ay maaaring maging attractive or not attractive sa presence ng magnetic field. Kapag ang orbital ay may presence ng unpaired electron, gaya ng sa nakikita natin sa element number 1, ito ay tinatawag nating paramagnetic kung saan ito ay attracted to the presence of magnetic field. At kapag ang orbitals naman ay filled with paired electrons gaya ng sa elements number 2 and 3, ito ay tinatawag na diamagnetic kung saan hindi ito naaapektuhan ng magnetic field. Ngayon, pwede na nating isulat ang electron configuration ng aluminum na may atomic number na 13. Tandaan, kailangan nating may apply ang tatlong principles or rules sa pagsulat ng electron configuration. Muli, kailangan nating gumamit ng electron configuration mnemonic device upang malaman natin ang tamang pagkakasunod-sunod ng energy levels mula sa pinakamababa hanggang sa pinakamataas na energy level batay sa ating pagsunod sa Aufbau principle. Kung kaya, ang aluminum ay magkakaroon ng electron configuration na 1s2 kung saan, muli, ito ay ayon sa Pauli's exclusion principle na sa isang orbital, ito ay nag-a-accommodate lamang ng isang pair of electrons na nagpapakita ng opposite spin. Sunod ay ang 2s2 followed by 2p6. Sa bahaging ito, ipinakita lamang na inuna muna natin ilagay ang mga electrons na represented by line ray facing upward sa bawat orbitals ng sublevel ng 2p. At saka naman natin inilagay ang kapareho nito na line ray facing downwards alinsunod sa konsepto ng Hund's rule. Kasunod ay 3s2. Bago tayo tumuloy, i-add muna natin lahat ng mga naka-superscript. Ngayon, ito ay may 12 electrons na at nagtapos sa 3s2. Mapapansin natin na isang electrons na lamang ang kulang nito upang ma-fulfill ang 13 electrons. Balikan natin ang mnemonics. Mapapansin na natin na ang sunod sa 3s ay 3p. At ang p sublevel ay may maximum number of 6 electrons. Ibig bang sabihin nito ay 6 na agad automatically ang ilalagay natin na number of electrons o sa superscript nito? Ang sagot ay hindi. Dahil tulad ng sinabi natin, kailangan ang total distribution of electrons sa bawat sublevels or orbitals ay equal dapat sa atomic number. Dahil nang tinotal natin ang kasalukuyang distribution of electrons ng aluminum, ito ay may 12 electrons na. Ito ay nangangahulugan na isa na lamang ang kulang, kaya ang kasunod ng 3s2 ay tama, 3p1. Kung babasahin natin ng maayos ang electron configuration ng aluminum, ito ay may electron configuration na 1s2, 2s2, 2p6, 3s2, 3p1. Kung i-add natin ang distribution ng electrons o yung mga numbers na naka-form as superscript, ito ay equal sa atomic number ng nasabing element. Gaya ng napapansin natin sa naging resulta ng electron configuration ng element na aluminum, ito ay nagkaroon ng unpaired electron sa pinakamataas na energy level nito na 3p. Sa ating naging discussion, tinatawag nating paramagnetic ang isang atom kapag ito ay nagkaroon ng unpaired electron. Nangangahulugan na ang aluminum ay isang halimbawa ng paramagnetic atom, kung saan ito ay attracted sa presence ng magnetic field. To summarize this video lecture, electron configuration refers to the shorthand representation on how each electron is arranged among the orbitals, levels, and sublevels. Each levels have respective number of maximum electrons that can accommodate. Ang S ay may dalawang maximum number of electrons. Ang P ay may 6 na maximum number of electrons. Ang D ay may 10 maximum number of electrons, samantalang ang F ay may 14 maximum number of electrons. Pagdating naman sa number of orbitals, ang S ay may isang orbital, ang P ay may 3 orbitals, ang D ay may 5 orbitals, at ang F ay may 7 orbitals. In the distribution of electrons, we follow 3 principles. First principle is what we call the Aufbau principle. It means building up, which came from a German word. We need to start on the lowest energy level before we proceed to the higher level. Second principle is what we call Pauli's exclusion principle. It states that no more than 2 electrons in an atom can occupy an orbital. Ibig sabihin, sa loob ng isang orbital or box as a representation, ito ay may pair of electrons lamang o hindi hihigit sa 2 electrons. The third principle is what we call the Hund's rule. Electrons can occupy orbitals of equal energy. Kailangan malagyan muna natin ng isang electron ang bawat orbitals bago natin ilagay ang magiging kapareho ng bawat isa. Nalalaman din natin na ang pagkakaroon ng unpaired or paired electrons sa orbitals na makapagsasabi kung ang atom o element ay magiging affected sa presence ng magnetic field. Ito ay may 2 uri. Una ay ang paramagnetic, kung saan ito ay may presence ng unpaired electrons, which is it is being affected with the presence of magnetic field. Ang pangalawa naman ay tinatawag nating diamagnetic, kung saan ito ay may presence ng paired electron o ang lahat ng orbitals ay filled with paired electrons. Ito ay nangangahulugan na hindi ito affected sa presence ng magnetic field. Ngayon, Subukan natin kung nakasunod ka sa ating video lecture. Kumuha ka ng lapis at papel at subukan mong isulat ang electron configuration ng mga sumusunod na elements. Pagkatapos, alamin mo kung ito ay isang halimbawa ng paramagnetic or diamagnetic atom. Maaari mong i-post ang video na ito kung talagang desidido kang masagutan ang mga halimbawa na ipapakita. Maaari mo ring isulat ang iyong sagot sa comment section ng video lecture na ito para magkaroon tayo ng interaction. Item number 1. Phosphorus with atomic number 15. Time's up. Muli, sa pagsulat ng electron configuration, sinusunod natin ang tatlong principles. Una, ang Aufbau principle. Pangalawa, ang Pauli's exclusion principle. At pangatlo ay ang Hans rule. Ang electron configuration ng phosphorus ay 1s2, 2s2, 2p6, 3s2 at 3p3. Muli, sa pagsulat ng electron configuration, nagsisimula tayo sa pinakamababang energy level hanggang sa makamit natin ang pinakamataas na energy level. Dahil sa pinakamataas na energy level, ito ay nagpakita ng unpaired electrons. Ito ay isang halimbawa ng paramagnetic atom. Now, let us proceed to the second item. Oxygen with atomic number 8. Time's up. Ang oxygen ay may electron configuration na 1s2, 2s2, at 2p4. Dahil sa pinakamataas na energy level ng oxygen, ito ay nagpakita ng unpaired electrons. Ito ay isang halimbawa ng paramagnetic atom. Sana ay may natutunan ka sa video lecture na ito tungkol sa pagsulat ng electron configuration. Sa susunod nating
Okay, salamat sir sa napaka-detalyadong explanation para sa ating electronic configuration. So guys, thank you for watching and I hope na marami kayong natutunan sa part 1 ng ating video na ito. Muli, this is Mrs. Rose and V. Parane at abangan na ating electronic configuration part 2 discussion. Goodbye!